There has been a nuclear accident in the Soviet Union, and the Soviets have admitted that it happened. The Soviet version is this. One of the atomic reactors at the Chernobyl atomic power plant near the city of Kiev was damaged, and there is speculation in Moscow that people were injured and may have died.
So there are 5 major challenges to deal with to either prevent a nuclear power attack or to deal with the aftermath of a nuclear power attack. The first one is how to keep the material in security to make sure that it does not fall into the wrong hands. The second one would be how to detect the material so that we can know if there is nuclear material, for example, in a shipment container. The third one would be how to render a potential device harmless, so how to defuse a nuclear bomb. And there are also 2 challenges with dealing with the aftermath of a nuclear attack. So the first one would be to have an appropriate emergency response, cleanup, and public communication after a nuclear explosion. And the other very important one would be to determine who did the actual attack. So all of these have engineering components, some are purely technical, and others are system challenges. It is very obviously essential to have a sound system to keep track of weapons and nuclear materials known to exist so that we can protect against their theft or purchase on the black market. Another potential danger to keep in mind is that some terrorist organizations could buy the innards of a dismantled bomb and study said dismantled bomb to actually replicate it and build a homemade explosive device. So there are a couple of possible engineering solutions presented. So one of them would be to develop a passive device that would be situated near a reactor, which could transmit real-time data on the reactor's content. This would mean that we would be able to detect if there is ever a removal of plutonium. Such devices are already being designed and tested. Another very important challenge to face is that, well, there are already legal shipments that are done within large shipping containers. So we would need to be able to detect the nuclear materials inside these big shipping containers. One of the approach has shown promise, nicknamed the nuclear car wash. So basically it is a scanning system that containers would pass by on a conveyor belt. As the container would pass the device, they would receive pulses of neutrons, a common subatomic particle often used to induce nuclear reactions. In this case, the neutrons would induce fission in any weapon-grade nuclear material within the container. The fission, in turn, produces radioactive substances that would emit gamma rays, a form of radiation that could be reliably detected from outside of the container. Still, it leaves residual radioactivity and could be shielded with a large amount of water. Higher energy X-rays leave no radioactivity and may even be able to detect shields against their beam, but the problem is that they would damage sensitive material like photographic film. No doubt, other nuclear challenges will surface and additional engineering methods will be needed to protect against a variety of possible nuclear assaults. But the ingenuity of system and nuclear engineers and the deep understanding of nature's nuclear secrets provided by our basic physics research offer encouragement that those challenges can be met in the 21st century.
Okay, so now we're going to talk about how engineers and people in other fields can have an impact on avoiding a nuclear terror. A nuclear reactor, in broad terms, is a chemical process plant. It relies on the chemical properties of radiation to generate energy. Therefore, to incorporate any means of surveillance or modification to the plant, the expertise of a chemical engineer is important for planning an efficient and effective method. For example, the principal chemical problems in the primary heat transport systems of power reactors are the decomposition of the coolant, corrosion of system materials, the deposition of material on fuel heat transport surfaces, and the generation and transport of radioactive nuclides. And it's chemical engineers that are the ones who would have to face these problems and improve these issues into something better. To materialize this principle, appropriate hardware is going to be required. So the expertise of electrical and mechanical engineers are required to materialize a solution into an applicable hardware. There may be restrictions like space, cost, size, etc., which electrical and mechanical engineers are adept at working through. For example, a chemical engineer can design a method of detecting unauthorized nuclear material by utilizing the chemical properties of them. But however, they do not have the necessary skill sets nor experiences to create hardware that can execute such methods in real-life applications. So the chemical engineers must cooperate with electrical and mechanical engineers, who are more adept at developing hardware to successfully materialize their solution. This shows the interdependencies of engineering disciplines in solving problems. We know that almost all nuclear energy is produced by the private sector today, but while it would be very difficult to coordinate all of industry, a government regulation can efficiently do so. As such, to actually incorporate their solutions, engineers would need to collaborate with those in the discipline of political sciences to endorse a government policy. Moreover, engineers will likely be involved with legal concerns, in which case they must cooperate with those working in law. These fields are completely out of the knowledge of engineers, but nonetheless a very important aspect of problem solving in real life. Engineers must work with others outside of the engineering field to properly implement their solution into use in society. Thank you.